Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter Summation of Trigonometrical Series lecture number 3, in which I will solve some more problems on sum of sine and cosine series in which angles are in AP. Now we solve a problem. Problem is find sum to n terms of the series. Number 1, sine alpha minus sine alpha plus beta plus sine alpha plus 2 beta minus sine alpha plus 3 beta plus dot. Number 2, cos alpha minus sine 2 alpha minus cos 3 alpha plus sine 4 alpha plus cos 5 alpha minus dot. Since sine pi plus theta equal to minus sine theta, sine 2 pi plus theta equal to sine theta, sine 3 pi plus theta equal to minus sine theta, sine 4 pi plus theta equal to sine theta, and so on. Using these in 1, we get number 1. This is sine alpha, and value of this may be written as sine pi plus alpha plus beta plus sine pi plus alpha plus beta plus, we may write this sine 2 pi plus alpha plus 2 beta. We may write this plus sine 3 pi plus alpha plus 3 beta and dot. This equal to sine alpha plus sine alpha plus pi plus beta plus sine alpha plus 2 pi plus beta plus sine alpha plus 3 pi plus beta plus dot. This is number 1. Since alpha plus pi plus beta, alpha plus 2 pi plus beta, alpha plus 3 pi plus beta dot are in AP, such that first term equal to alpha, common difference equal to pi plus beta. Therefore, 1 may be written as sine in beta, common difference, pi plus beta by 2 by sine, common difference, pi plus beta by 2 multiply sine, first term alpha plus n minus 1 by 2 common difference pi plus beta, which is the required result. Number 2. The series may be written as cos alpha, here minus sine 2 alpha. We may write this cos alpha plus cos 2 alpha plus pi by 2, cos pi by 2 plus theta equal to minus sine theta plus cos 3 alpha plus pi, cos 3 alpha plus pi equal to minus cos 3 alpha plus sine 4 alpha is cos 4 alpha plus 3 pi by 2. This is in fourth quadrant, so this is positive, and dot 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 dot. This is equal to cos alpha plus cos alpha plus alpha plus pi by 2 plus cos alpha plus 2 alpha plus pi by 2. This is alpha plus 2 alpha equal to 3 alpha, and this is pi, 2 multiply pi by 2 plus cos alpha plus 3 alpha plus pi by 2. This is alpha plus 3 alpha is 4 alpha, and here 3 pi by 2 plus dot 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 equal to here alpha plus pi by 2, here alpha plus 2 alpha plus pi by 2, here common difference of angles be alpha plus pi by 2. So sum will be sine in common difference is alpha plus pi by 2 by 2 by sine common difference alpha plus pi by 2 by 2 into cos, first term is alpha plus n minus 1 by 2, common difference is alpha plus pi by 2, which is the required result. Now we solve the next problem. Next problem is find the sum of the series sine square alpha plus sine square alpha plus beta plus sine square alpha plus 2 beta plus dot 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 plus sine square alpha plus n minus 1 into beta, and hence deduce the sum of the series 1 square plus 2 square plus 3 square plus dot 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 plus n square. Now we solve this. Since cos 2 theta equal to 1 minus 2 sine square theta implies that 2 sine square theta equal to 1 minus cos 2 theta implies that sine square theta equal to 1 minus cos 2 theta by 2. This is number 1. Using 1 in the given series, we get the sum equal to sine square alpha is 1 minus cos 2 alpha by 2 plus sine square alpha plus beta 1 minus cos 2 alpha plus beta by 2 plus sine square alpha plus 2 beta 1 minus cos 2 alpha plus 2 beta by 2 and plus dot 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 2 in terms. This is equal to half plus half plus dot 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 2 in terms minus cos 2 alpha plus cos 2 alpha plus 2 beta plus cos 2 alpha plus 4 beta, and here we have a half plus dot 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 2 in terms. This is equal to in multiply half plus half plus half 2 in terms minus half. Here we see that common difference is 2 beta. So sum of this series is sine in multiply common difference 2 beta by 2 by sine 2 beta by 2 into cos. First term is 2 alpha plus n minus 1 by 2. Common difference is 2 beta. This is equal to n by 2 minus here half multiply 2 cancel sine n beta by sine beta. Here cos 2 alpha plus here 2 cancel n minus 1 beta. This is the required result. this is number 2. Let beta equal to alpha, then sine square alpha plus sine square alpha plus, in place of beta, alpha plus sine square alpha plus 2 alpha plus dot 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 plus sine square alpha plus n minus 1 alpha equal to, here n by 2 minus half sine n alpha by sine alpha, here cos 2 alpha plus n minus 1 alpha, implies that sine square alpha plus sine square 2 alpha plus sine square 3 alpha plus dot 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 plus sine square, here plus alpha, here minus alpha, cancel, n alpha equal to n by 2 minus half sine alpha n alpha by sine alpha, here cos, here 2 alpha, here minus alpha, then alpha plus n alpha. Let this is number 3. Right hand side equal to n by 2 minus half sine n alpha by sine alpha cos alpha plus n alpha. This is equal to n by 2 minus half, multiply, here 2 cos alpha plus n alpha multiply sine n alpha by 2 sine alpha. This is equal to n by 2 minus, here 1 by 4, 2 to 1 by 4 sine alpha, here 2 cos A into sine B is sine A plus B alpha plus n alpha minus sine A minus B alpha plus n alpha minus n alpha. This is equal to, we take LCM, 4 sine alpha, here 2n sine alpha minus, here sine alpha plus 2n alpha minus sine alpha. This is equal to 2n sine alpha, here minus minus plus sine alpha minus sine 2n plus 1 alpha, here we take common alpha, by 4 sine alpha. This is equal to 2n plus 1 sine alpha, we take here sine alpha common, minus sine 2n plus 1 alpha multiply by 1 by 4 sine alpha. This equal to 1 by 4 sine alpha. Here 2n plus 1, we expand sine alpha. Alpha minus alpha cube by factorial 3 plus alpha to the power 5 by factorial 5 minus dot 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 dot. Here we expand this minus 2n plus 1 alpha minus 2n plus 1 whole cube alpha cube by factorial 3 plus 2n plus 1 whole to the power 5 alpha to the power 5 by factorial 5 minus dot 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 dot. This is equal to 1 by 4 sine alpha. Here 2n plus 1 alpha minus, here from the second bracket we get 2n plus 1 alpha. From the first bracket we get minus, we take common 2n plus 1 alpha cube by factorial 3. 2n plus 1 alpha cube by factorial 3. Here in the first bracket remains 1, and here in the second bracket we have already taken minus, so remains minus 2n plus 1 whole square. Now we take common 2n plus 1 alpha to the power 5 by factorial 5. Here remains 1, and in the second bracket minus 2n plus 1 to the power 4 and minus dot 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 dot. Here we take common 2n plus 1, this is 2n plus 1 alpha and 2n plus 1 alpha cancel. We take common 2n plus 1 alpha cube. We take common from each term. By here we have 4 sine alpha. So remains here 1 by factorial 3. Here 2n plus 1 whole square minus 1 minus alpha square by factorial 5. Here 2n plus 1 to the power 4 minus 1 and plus dot 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 dot. Let this is number 4. Therefore from 3 and 4 we get sine square, this is sine square alpha plus sine square 2 alpha plus sine square 3 alpha plus plus sine square n alpha equal to 2n plus 1 alpha cube by 4 sine alpha. Here 1 by factorial theory, 2n plus 1 whole square minus 1 minus alpha square by factorial 5, 2n plus 1 whole to the power 4 minus 1 and plus dot. Let this is number 5. Dividing both sides by alpha square, we get sine alpha whole square by alpha square plus sine 2 alpha whole square by alpha square plus 3 alpha whole square by alpha square plus dot plus sine n alpha whole square by alpha square, and this will be equal to, in right side alpha square will be cancelled, so here there will be only alpha, so this is equal to 2n plus 1 alpha by 4 sine alpha 1 by factorial theory 2n plus 1 whole square minus 1 minus alpha square by factorial 5 2n plus 1 to the power 4 minus 1 plus dot implies that sine alpha by alpha whole square, here we write 1 square, plus we write sine 2 alpha by 2 alpha whole square, here 2 square, so here we write 2 square plus sine 3 alpha by 3 alpha whole square, here write 3 square plus dot plus sine n alpha by n alpha whole square, here we write n square equal to, here we write 2n plus 1, here sine 4 sine alpha by alpha 1 by factorial theory 2n plus 1 whole square minus 1 minus alpha square by factorial 5 2n plus 1 whole to the power 4 minus 1 plus dot. Taking limit alpha tends to 0 and using limit theta tends to 0 sine theta by theta equal to 1. Let this is number 6. We may write 6 as 1 square. This is 1 plus 2 square. This is 1 plus 3 square. Multiply 1. 1 means here 1 square plus dot 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 plus n square. Multiply 1 square. And this will be equal to, here this will be 1, 2n plus 1 by 4 into 1, 1 by factorial 3, 2n plus 1 whole square minus 1 and minus 0, because each term contains alpha as coefficient and alpha is 0, equal to 2n plus 1 by 4, 1 by factorial 3 is 6, here 4n square plus 4n plus 1 minus 1. 1 and 1 cancel. This is equal to 2n plus 1 by 4 multiply 1 by 6. Here we take common 4n. Here remains n plus 1. And this will be equal to 4 cancel. N into n plus 1, 2n plus 1 by 6. Therefore, here 1 square plus 2 square plus 3 square plus dot 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 plus n square equal to n into n plus 1, 2n plus 1 by 6. This is the required result. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.